Greetings, everybody. My name is Floyd Christofferson from Hammerspace, and I'm joined here by my partner in crime, Brian Bashaw, Field CTO from Hammerspace. Hey, Brian.
Hey, Floyd.
Thanks for joining everybody on this LinkedIn Live session, where today we want to tackle a topic on automation. And we're talking about unstructured data and how to automate data management and data movement across storage silos. And let me just kind of tee up, but before I do, this is interactive, so please in the chat put any questions that you may have, and then we'll get to them over the course of it, and we will try to work our way through this. So the basic topic here that we really want to address is the problem of unstructured data management across silos. So, you know, in the reality in the world that we're living is that data, people access data through file systems, right? So if you look at this graphic, you know, the file system is really what interprets all those bits and bytes on the drives so that people can see files and folders and know what's in there. The problem is, and this is the problem that, you know, Brian, that we've seen throughout the history of data management across storage, is that when that storage device fills up, another storage device is needed, or when a different performance or different economics is required. That the problem is that now people need another file system. The file system itself is embedded in the storage platform, and so how do you see your files if you're accessing it through a file system and the file system is trapped in the actual infrastructure layer, right, Brian?
Yeah, and you know, I think even right out of the gate, just looking at the two file systems here, there's an activity that happens, and whether or not admins recognize that they're doing it or not, it happens, and it happens every day by everybody that interacts with the storage system. Forget enterprise, you know, storage arrays for a second. Just think about your own laptop or your own workstation. You know, how many times have you gone and set up a new directory and by yourself manually walked down and created a directory structure that represents the project you're working on and the stages of that project and different deliverables, or labeled documents as draft, or, you know, all these things are, whether you realized it or not, you're manipulating metadata, but you've also now been sort of conditioned to have to do that each different time you move into a new world. And it's up to you to do it and hope the rest of the people that are interacting with that data are doing so in a consistent and unified way, right?
Yeah, I mean, you know, I think about it, think back into the 90s, right? You know, when the file system was actually part of the operating system. I mean, especially people my age, we all remember.
Our age, Floyd. Our age.
Okay. All right. So, you know, we all remember working on a file, right? And, oh, you want to share it with somebody. How do you do it? You put the file and its metadata onto a floppy disk, pop it out of your machine. So out of the file system is in your machine, actually. Hand it over the wall to somebody else, and hand it over to the wall to somebody else. Now they have a copy of that file and its metadata. They pop it in their machine, and now you've got two forked copies, right?
Yeah, the good old sneaker net, as we used to call it, right?
That's right. And so the problem then is, okay, and so that was fine. You now have two copies and you'll collaborate on them. And so things got much better when the file system was elevated out of the individual operating system, and now it was on the network. And so, you know, now you and I could be working on the same file, on the same metadata, sitting on our NAS device on the network, right? The problem then is, what happens when that network file system fills up, right? Or you need other storage. Don't you get back to the same problem you had before?
You do, or as you know, you get a new compute engine that's capable of driving more, or demanding more, if you will, from the storage entity that was feeding it yesterday just fine, but today now you find you're paying expensive compute cycles in wait IO state. And so it doesn't even have to be the fault of the data or of the admin or the capacity engine filling up as much as it is other changes in the environment will drive an evolution of that storage infrastructure. Then
Right.
you add into that this idea of multiple locations maybe interacting with that in different ways at different times, and it starts to get even more complex.
Right. So, I mean, the fundamental problem is that people deal with metadata, and let's pause a second and talk about what metadata is, right? Because over the course of this conversation, I want to talk about more than one type of metadata, right? Because we've already talked about how accessing the file system is one type of metadata, the file name. What are the other types of things that are in file system metadata?
Yeah, I mean, certainly that directory structure by itself might be descriptive of the data set. File types, access time, creation time, M time, owner, group, there's a number of different properties that can be associated with that traditional metadata. Then there's even, embedded metadata. For example, I grew up in seismic processing, and one of the things that we always looked at was the different format headers that could be applied to different data sets. And so you might have within that format header something that says this is the latitude and longitude associated with a data set where it was acquired. Similar traits exist in a normal photo, for example. So there's things that can be embedded in the header of a file, but now move from one file format to another, and the header formats might vary as well. And so you're back into that odd, inconsistent state of how do you look this stuff up? How do you leverage it in an easy, consistent, predictable way? And that, kind of to segue for a second, that was one of the promises, at least in my mind's eye, of object storage. I think object storage, right or wrong, sort of fell into this place of it's the cheap and deep thing that you put behind something else. But one of the cool traits of object store is that customizable metadata, that ability to have those attributes defined by a user or the consumer of that data and have it live with that data in its life cycle. I think the challenge is just like we opened up with, Floyd. It's this idea that I've got this bucket, no pun intended, of data that I can assign attributes to. But if I need to consume that over an SMB protocol by a different instrument somewhere else, well, then getting access to that is no longer an easy thing to do or to maintain.
Sure. So let's skip forward a bit. And again, for those just joining us, this is Hammerspace Live, where we're talking about automation of unstructured data across silos. And those silos might be two different NASs in a data center, or as you mentioned, Brian, people are adding object store to go cheap and deep. And certainly there's much more need for people to go beyond the data center into the cloud. And so, we've got the file system, as we've described, where, if I'm accessing part of my data, and we're talking really, this is not just, Google Docs level unstructured data where you've got a few files and a few Office files. This is workflow where you are in a genomics pipeline and you're generating images out of an electron microscope, or you're in a media and entertainment pipeline and you're building elements. And these elements are not going to fit on one storage device, and they may need to be collaborated with. And so you've got different touch points for this data, right? But and also, I mean, even just when you go into the data, I always like to say the data outlasts the storage it's on, right? And so what happens when you have to migrate that data off of old storage to new, or you merge two companies and so forth? And so let's talk about this problem a little bit of, the reality that we're dealing in, where the file system traditionally has been locked into the infrastructure layer. And so now you've got to do all of this migration, data services, and data services includes data protection, it includes maybe deduplication, it includes movement of data, it includes, what are the other types of data services that people need to deal with, especially in a siloed environment?
Yeah, I mean, I like to think of things in terms of real world examples. And Floyd, you and I had the privilege of sitting with a gentleman at the supercomputing show just a few months back. And a problem statement was presented to us that I think colors in and touches an awful lot of this. And that was, there's an instrument sitting on a network somewhere. And actually, in this case, there were multiple instruments sitting on a network. And those instruments, just by design, if you just look at them in their singular approach to data management, their idea was, well, I've got a Windows host sitting right next to me on this lab environment, and as I ingest content, I'm going to place that locally into this Windows system, and it should be good, except that now I've got storage that's trapped in that Windows system and capacity that's being held by that data set. Meanwhile, this multi-million-dollar instrument sits here idle while I wait for some data movement to take place. So
that's right.
Initial problem statement number one, how do I continue to drive value out of an instrument that's suddenly decided on its own to trap my storage resources? And you start getting into right away this idea of how do we apply these metadata objectives to migrate data off of that local host, to actually say, let's go ahead and receive that locally. We'll satisfy the workload requirement of that instrument. But now reach into other attributes of that. We can identify what instrument it was, what was the workflow, who was the user, what was the project, and define ahead of time a life cycle associated with that automatically gets triggered when that file's closed. We can just automatically start moving things over. We can apply these attributes in real time and have data ultimately go where it's going to live in perpetuity, rather than have to be an interactive step that somebody sets up manually or after the fact.
That's right. That's right. So, I mean, the data services then relates to how you're placing the data, when you move it, how you might take it or migrate it from that instrument or out of a render farm or wherever it may be, or in seismic processing where you're taking, source data that may never change, but you want to do post, analysis of this. So you're moving these things around. So with the file system trapped in individual storage systems, a whole ecosystem of point solutions has been developed around this, right? I mean, you come from a background that has been much more hands-on with this stuff than me. Describe a little bit how IT people manage all these different point solutions to move data around.
Well, there's how they manage it, and then there's the things that they probably don't do but should. So thinking about it from the perspective of what should be done, I think a lot of these decisions have to start not in the IT organization at all. In Hammerspace speak, we call them objectives when we think about this evolution or placement of data. But we use that word purposefully. These are business objectives. They aren't IT objectives. So, I think first off, we need to start with this idea of what is important to the business. What is our product? And if that product is seismic research or genomics research, or even just what image to show me next as I'm shopping online, whatever that business objective is, that should drive the life cycle of that data set and be able to be applied universally across all those data sets. But then you start getting into things like, okay, well, what's the most cost-effective approach to that? We had another conversation actually just recently, this week or last week, internally, just talking about data center objectives and what matters to people that actually manage data centers. Mm-hmm. And there was this idea, this place where you go of somebody somewhere knows the cost per square foot of that data center. Not only the cost of a storage silo sitting within it, but the cost per rack unit hosted in that data center. So when we start thinking about how do we optimize for those things, then you start thinking about, okay, well, data on ingest has these performance traits or these data protection traits, or the cost of reconstructing a data set is X. So you start kind of dumping all those variables out and thinking about, well, where should data land on ingest? Where should data land once we've confirmed that it's actually good and we want to hold on to it? What data doesn't matter? What data does it cost more to store than it does to recreate? And so you start applying some categorizations to these things and start mapping out what that evolution or that life cycle should look like. And then to your point on point solutions, you start looking at maybe you get lucky and within a chosen vendor's ecosystem, there's a way to do it behind the scenes. Often that still requires a separate physical silo somewhere. And maybe those tools still work pretty well together. But that decision works for today. In 2 years, some new technology comes out and you want to implement that, and chances are now I've got to go get a third-party lifecycle management tool or an HSM tool or something else that's going to further inspect the data, further get in the data path, further be something else I have to manage.
Sure.
And then it just kind of starts cascading from there. That stuff, you start thinking about disaster recovery replication. How do you employ that? How do you make that consistent across the board? So yeah, it's being a data management architect or a data manager. It's an easy thing to say. It's not an easy thing to do necessarily.
Thanks. Yeah, you're right. And again, if you're joining us here on LinkedIn Live, this is Hammerspace Live, and we're talking automation of data, data management, data placement, data services across siloed environments that might involve multiple vendor storage solutions, might involve multiple sites, and more typically and more often it involves the cloud as well. If you have questions, please put them in the chat and they'll be relayed to us, and we'll address them as we can through the presentation. So you bring up a good point, and that is, if you had all of your data on just one storage device, right? One massive storage device, then the problem goes away, right? Because the user the core of the problem here is that when you start moving data from one place to another, you're interrupting your users and your applications. So back to the genomics pipeline, if you're moving it from one device to another, which you have to, you're either interrupting your users, you're forcing your users and your applications to now look to a different place, but you're also burdening IT with, well, I got to actually make those data movements. I've got to do these things. If it were all in one big bucket, one giant storage NAS that everybody could see and everybody was fat and happy just looking at that, then it wouldn't be a problem, right?
Yeah, and it's again an easy thing to say, not necessarily an easy thing to do. And you start thinking about, how do you tell people that data lives in a new place? How many times have you done it? Gone looking for, you decided to reorganize. You did spring cleaning over the holidays and moved some stuff around, and now even in your own mind, you can't figure out where your own stuff is.
So that really brings us to the next topic, which is how we address automation. And again, automation is a scary word, right? Because often you think of automation and it's like, oh, who do we have to hire who can really manage automation?
Where's my DevOps?
Let's set the stage here for that. And I want to set the stage because we talked about creating a giant NAS. We talked about managing data across silos. We talk about the point solutions and the sort of the manual processes to do that. But with Hammerspace, what we've done is address this at the fundamental root layer. And that is by elevating the file system. And so Hammerspace, for those of you who don't know, Hammerspace is a software solution that is designed to manage data across these different silos. And so what that means is that we've elevated the file system out of the actual storage layer. So people need different types of storage. So on the left-hand side, if that's what we call a storage-centric IT layering, where the actual file system itself is embedded in the storage system, that means that the data management bit on the top, like we described, that's where you're moving the data back and forth through point solutions and other things. But if you flip it around, and that's what Hammerspace does, on the right-hand side, taking a data-centric approach, is you leave the data can be on any storage it needs to be, but you now elevate that file system so it's global, that it can bridge across any of the storage, right? Now, the applications and the file system and the users are right next to each other, so that any of the data orchestration that can go on behind the scenes is transparent, right?
Yeah, and I think it's important to point out too. I mean, we describe what Hammerspace does as a software suite, a software-defined set of tools that help you accomplish this data-centric approach. But I think it's important to notice that the one bit that moves in a major way is that file system. And that means that we are that file system. It's not that we're some sort of external component that just sits out on the network and passively participates in this approach. We are actually providing that entire point of view, that entire file system across the top of that data orchestration. Or maybe said differently, if you look at the left-hand column here, the storage-centric approach, some of those applications are the point solutions, the HSM software, the ILM software. Those are those applications, and they have to reach past the data management and storage system layer to go manipulate the file system in ways that are sort of unnatural because of the limitations of that file system. By promoting it on, we can actually reduce those applications and bring that back to users.
So exactly. So hang on a second. So again, if you're joining us, this is LinkedIn Live, Hammerspace Live, where we're talking about automation. So, okay, Hammerspace has, and please put questions in the comments. We'll get to them as we can. So, so we've elevated the file system out of this. So this is a bit of a paradigm shift. So from the point of view of a conventional IT approach, you're used to dealing maybe with the complexity, but if you can now have this, ideal world, as it were, where the file system is up here, this changes the game, right?
Yeah, absolutely. Now all of a sudden, I'm not having to stitch together different file systems. I can treat the file system as a constant. And different storage systems, physical storage systems that exist in my infrastructure, become providers of capacity, providers of data protection. They have their own capacity efficiency engines that can still be leveraged. Snapshots, for example, can still be leveraged at the way that they do them, tying into the way that we do them. But they now just become extra providers of capacity rather than they are the owners of that trapped layer of metadata. That's what elevating it lets us do.
So let's talk about the key word here, and that's automation, right? So we've talked about the different kinds of data services that may be needed. We've talked about the fact that we're bridging these, and about how we've elevated the file system out. So there's a control layer that comes in with this, right? So that file system becomes, for want of a better term, a metadata control plane, right? And so how do we automate this? And maybe let's kind of go back and forth a little bit on, the way a conventional IT environment might try to manage this versus what we can do with Hammerspace to automate, and start to peel that back a bit.
Sure. I think one of the most basic things most everybody's probably seen or dealt with in a data management world is just a simple lifecycle management. How do I either apply an archive policy or something that says take inactive data from expensive place to lower cost place? So it might be used in a third-party way. There's various point solutions that solve for this kind of a problem. Mm-hmm. But what would you do differently if you could do something that said, I don't care about the difference between storage vendors, or I don't care to have to sit down and apply a different lifecycle management policy to every directory? Like, what are some of the things that you would do differently if you could?
That's right. I mean, and then maybe that's a good way to get into this, and that is you touched on it earlier, and that is objectives, right? So if you've got that control layer on the top, and you can define, give us an example of what an objective might be, where you're dealing with global snapshots, for example.
Sure. So before we jump into global snapshots for a second, one of the cool things, just to tie in this ease of automation and maybe relieve some of that stress you may be feeling as you're trying to spin up your Python skills. One of the cool things that Hammerspace will do is when we define these different storage systems that are going to participate in that service, that storage service, is we'll also profile that storage system. We'll define behind the scenes what sort of performance characteristics, for example, we can get out of that. So now if you just take those two traits and then maybe add a cost metric associated with them and start to define the building blocks that are there, then start stitching in this life cycle of snapshots. you could, in fact, create an objective inside of Hammerspace land that says, you know what, my original data lives on NAS01. I want to trigger a snapshot that is globally consistent across all users. That's cool in and of itself. But now any deltas that are created, any changes that are protected by that snapshot, instead of protecting those on the same tier of storage that's hosting my primary data, wouldn't it be cool if I could just take those deltas and immediately place those to a globally consistent, deduplicated object store that's reachable by anyone? That I could recover those deltas in another region geographically on the planet? Like, I'm getting cost savings, I'm getting visibility, I'm getting, immediate access to this data protection engine, and all I had to do was apply this objective one time, and it's globally consistent everywhere.
So an objective then, as you said, this is like a plain language business rule, right? Where, in plain language, I say, okay, I want to protect all the data on all the silos, and I want to do it in this way. Or I want to, let's say, immediately upon that data landing in the cache of that genome sequencer or the electron microscope or out of the render engine, I want to create a wormed copy somewhere. So that means administrators now can use plain language rules that defines the outcome or the behavior that they want that data to take, right?
Yeah, that's right. As a matter of fact, there's a nice little point and click. You can almost visually draft what you want an objective to do as well, and start profiling that data lifecycle. And then, as you say, it's designed to be plain language friendly. If this, then not kind of language.
Sure.
And it's not uncommon for us as we're working with customers to say, hey, just tell us in plain language what you want, and we'll show you how it works behind the scenes and help sort of, act as that Rosetta Stone into a thing we call HammerScript, which we'll touch on at some point when we have another conversation, or maybe even today.
Sure. So, we've been talking primarily about, triggering via file system services, right? Or file system metadata. But, so how much is custom tagging and custom metadata, something that relates? You touched on it in the beginning in that there's rich information in the headers of files, or there may be other information that is available to trigger, business outcomes really for the data, right?
Yeah, but take it back just a notch and just think about, workflow optimization. Another point solution that comes up if we can set aside lifecycle management for a second and think about caching. You used the word a moment ago. There are solutions associated with just delivering cache effectiveness at an edge location, or at some other place where compute's going to happen that's distant from the data. But one of the things that often comes up when you think about caching is, well, how do I prime that cache? How do I make it so that users don't feel the burden of that first access? How do I make that simpler? And so just in that world, if a workflow is going to need that remote benefit, that cache-like experience, well, what if you could identify based on metadata attributes there? Access time, performance profile, what sort of IOPS are being requested of that file might mandate that I'm going to move that somewhere else. Or just simply, how old is that file, or who's accessing it, where and why, all become traits that I can leverage things like caches. But I can do that now regardless of where the data set not only was born, but where it lives now. And do so across many different entities. So it's not just trapped in object land, it's actually available no matter what protocol I request that on. A file can originate from an instrument in a lab over an SMB share, and then turn around and be leveraged by an HPC farm over an NFS connection, and get access to all the same consistent metadata.
But that custom metadata, or that real information, the business rules type information, that's more than just access time, file size,
right,
date, and so forth. It may be the project ID. It may be the cost center. It may be, is there compliance related information in here? Or in, like in an iterative process in cryo-EM, where you may start with one model, right? And you're running it again and again. Eventually you're going to have a final, right? So what do you do with the final? So, isn't this custom metadata something that needs to be taken into account when you're dealing with how you protect it? I mean, do you protect the scratch data in the same way that you protect the final? Do you collaborate with the scratch data in the same way you collaborate with the final? And so can custom metadata then be used to trigger all of these things?
It can be. You also, though, have to make sure that you're presenting it in a consistent way, making sure that, typos happen. Sometimes people put underscores instead of dashes, and so being able to not only leverage that metadata, but also define schemas that allow people, some guardrails in terms of how they define them as well, adds to that predictability. And so, you want to present this rich case or this rich library of attributes, but you also want to then apply those guardrails so that those objectives are applied in the same way every time, or at least with some good predictability, right?
Yeah, and that gets to one of my favorite topics, which is how you guard against the fact that humans screw up, right? So right over here on this screen, I've got Evernote, right? And I use Evernote all the time, and it's got the ability to tag. And so, but do I always remember to tag my notes so that I can search for them and easily find them? Mm-mm. Or, nope. And I've, going back for the last 15 or so years, talking with research, IT managers at research institutes or university, ask them, for example, how reliable are, research assistants or other people in identifying or classifying these non-file system related information? Which project, which grant reference, which job run, what's the machine ID and firmware version of the machine? So, and this gets to, I think, something that is really one of the most important and powerful aspects of Hammerspace in this ability to aggregate and manage metadata, and that's inherited metadata.
That's right.
Tell us a little bit about what that is and how inherited metadata can help eliminate the human error factor in this.
Sure. And so, to that point, if you kind of just rewind to the beginning of our conversation, we talked about this idea of creating a directory structure, and we're not going to change that. That it makes sense. It maps well to the way we think about placing data in a file system. But if you think about the metadata that you want to apply to that, if you could, as a data manager, define the attributes rather that you wanted to apply to those data sets and apply them at the parent directory, and just say any new file or folder that comes into play ever underneath this will always have these traits or can never deviate from these guardrails. So then all of a sudden you get this thing that no matter where data moves to later on, it always still has that metadata attribute of where it originated. It's kind of a log, a journal of that data's life cycle in a simplistic way. In a more evolutionary way, you can start tracking, to your point, like we've iterated on a data set. Let's add some of those components in based on where that data lives, and make those be things that are admin defined, user searchable, but not necessarily changeable. And then also be able to create other assets that are user changeable. A user might be able to right click on a file and say, I want to tag it with these things, like your Evernote example. But those things, that list, is defined by that storage admin. Being able to do those things in a global way and in a nice controlled way, but then also now empowering the user to make some of their own separate decisions, gives you that constant view, no matter where data's been or lives, as well as that ability to have users that want to take a little bit extra care of their data to do so, but do so within bounds.
So let's say that again. So an operator, and it could be a user, an authorized user, right-clicking in their Windows, being able to now attach a custom metadata tag, which may have been defined, to avoid fat fingering and misspellings and so forth. They can attach that metadata to a folder such that all of those files, for example, coming out of the electron microscope, they will automatically inherit that project ID, the job run, the firmware version, whatever somebody wanted to attach to that, right?
Yeah. I mean,
And
think
then,
about all the things that you might plug into a database to define that data set, but now make those entries be part of that metadata schema.
So if more folders are created down that hierarchy, additional tags, maybe job run number 2, 3, 4, 5, and final, right?
Yep.
So
Absolutely.
So let's talk then about what the objective means then. So, not only maybe I want to set an objective that manages, ages the data off of expensive storage to cheap when I don't have when it's not being used, but now with one click you could search for all of the data related to, project 1, job 1, grant reference 1, and initiate a rule that says, okay, I want all of these copies, I want all of these to migrate to cloud, or I want to send them off to another site where they're going to be, post-processing and analysis. So a user doesn't have to now go to an HSM tool or to a cloud gateway or anything. By simply tagging it with the metadata and then establishing that objective, that business rule, plain language rule that says, okay, anything that says final from job 1, I want it to be protected in this way and moved that way. But does that interrupt the user's access to it?
Not at all.
Not at all. It's a global file system, right?
That's right. If you think about that metadata layer, I mean, just forget all of the automation and the fun words we're using. Think about one of the fundamental responsibilities of metadata in any file system, One of those responsibilities is to make sure that we know what blocks data lives in or lives on within that entity. Well, again, by elevating that up out of that singular entity, we also take ownership and responsibility of that awareness of where the data lives. And it might live in one place, it might live in multiple places. And we can absolutely update that information on the fly, just as a deduplication engine might do on a normal traditional storage array. We can now bring that globally, yeah.
Again, if you're joining us, this is Hammerspace Live, and we're talking about automation of unstructured data, and especially when you get into very large volumes of unstructured data that may extend beyond different storage silos, may extend to different sites, may extend to one or multiple clouds. And so we've talked about how these plain language rules, right? And I like to call them business rules. It's not maybe necessarily technically correct, but essentially that's the way I think of it. How, I can pick an attribute. It could be the file size. It could be when it was created. It could be when it was last accessed, or it could be which department it is in, or an automated tag that says, hey, there's compliance information in this file. This has to be treated differently, right?
Yeah, and it could be any combination of them. And that treated differently, it's use your imagination. It's pretty fun to just get in there and look at even just the predefined things that are in the system. And yes, I use the word fun because nerd. But if you think about, just the ability to say if any of these or some combination of these metadata attributes apply, then always create previous versions, like always save versions of these specific files. They're prone to change. I want to refer to the last 7 of them, and I want those 7 previous versions to live in another storage entity elsewhere. Those are all things that are very easy to do and very automatable based on those business objectives. To your point, Floyd, I really like that point. I think it goes back to having these conversations with your business units, even with attorneys, to make sure that you're leveraging these in the ways that are responsible to your business. So
how easy is it really? I mean, how, do I have to hire a special automation engineer to come in and establish this, because I'm bridging different storage types, incompatible silos, locations. Yep. Up until now, I maybe have had to do this with, a variety of point solutions. So how easy is it?
This is one of the best parts. I think, I get to talk with people an awful lot throughout, just my normal day-to-day job. And we get to this point, and there's usually a moment somewhere in the meeting where someone calls me out like, yeah, I don't believe you. That can't be true. Prove it. Whatever words you want to use. And it's quite simple to show off. To your point, there's a handful of objectives that are, I shouldn't say a handful. There's about 30 or 40 of them that are already defined within a system between identification of tiers and then objectives that are already in the system. So there's plenty to choose from that you can then customize. There's ways to customize them within the GUI as a point and click using very simple, I want data to live on a fast tier. Here's what a fast tier means. I want it to live on a slower tier. Here's what slow tier means. All the way through to if you want to get crafty and start scripting it, you absolutely can, but you don't need to attend a course to even start that. You can define your first rule in those plain languages and then actually say, now show me the scripting language that represents that plain language view. And you can start learning and modifying from there as well. And quite honestly, that's what a lot of people will do is we'll stand up an initial environment for an end user. We'll apply those objectives interactively with them and then set them up to go off and start copying them and applying them programmatically later. So it's quite simple.
So and again, you're bridging any storage, right? So it doesn't have to be, Hammerspace is not storage. We're not putting it in our Hammerspace appliance and our Hammerspace NAS, and you got to, move all your data into a different storage system. This data lives on whatever storage you prefer based on your budget, the performance requirements, legacy storage that you already have in-house, right?
Well, and it's an important thing to call out because what that means is we're talking with you today about ways of automating data management and how you can leverage all the cool things of Hammerspace to empower you to execute on these things. But a lot of times that conversation also ends with, now let's take off all of the storage environment that you've already bought or already provisioned and do it on ours. And that's the part of the story you won't ever hear us. You won't ever hear us come in and start talking about. We will never point at your existing storage infrastructure and say, you've made a mistake, or you need to sweep the floor of that and install a bunch of Hammerspace branded storage. You've got that asset and it's got some level of importance. It may be brand new. It may be 10 years old, but for whatever reason, it's still there. Let's let you keep using it. But like I said earlier, if we overlay this file system across the top of everything, and again, if we're understanding of the fact and accepting of the fact that one of the responsibilities of that file system is to maintain an awareness of where in the world did I place those bits, well, then those bits could just be all the different storage tiers that you have in your environment today, as well as any new ones that show up tomorrow. One of the questions that I saw come into chat was around, how does this help with data migration? One of the hardest things about data migration, first off, is just orchestration with your users. Like, how do I remount shares? How do I do the cutover? How do I time all that? Well, once we've implemented Hammerspace and actually gone through this effort of we call it assimilation, of looking at all the data that's in the environment and populating our own namespace, that movement, that migration to another platform, because whatever reason, it's aged out, it's failing, you need to put something new in, whatever reason, all of that movement, that migration, completely transparent to the user. There is no more remount. There is no more changing of your mount structures or your data paths. They're all the same as they were yesterday. We've now just updated the pointer in our file system to say your content, your data now lives behind the scenes in this other place, and you don't ever have to worry about it.
And that actually ties in with a question that just came in, and that is, well, what happens with data that is in use?
Yeah, I mean, the other fantastic part about the way that we work, again, except the fact that we're a file system that lives up at the top, and I can't harp on that enough, that we're not just some sort of passive entity that's a metadata catalog that sits off to the side. We are aware of every transaction that's happening in the environment, and we can coordinate that movement of data behind the scenes independently of servicing access to your user community. They don't feel it at all, other than that we are now placing that content in different places.
Right. And I think that's a really key point here is that, users want to talk to their data, right? They want to see their data. They want to go to, whether they're on a Windows box or Linux or Mac or whatever, they want to see a file system, right? Their folders are there, their files are there, but all of the data services that we talked about, those would be, moving that data from one place to another and interrupting, the people, whether it's, whether even data protection, or tiering or other things like that. But if users don't have to be interrupted, right? So that they can just work. And then IT administrators can now manage data migration or let that data move to cloud without interrupting, even while they're actually working on the data. Isn't that somewhat revolutionary from a point of view of conventional IT?
Yeah, it's pretty powerful. And if you get the chance, I encourage you to reach out to us and let us show you how this works. We have a fantastic, simple, short way of visualizing it. We'll show you how you can create from an admin perspective these objectives, make it show you how easy it is to apply them. And then from a workflow perspective, we'll switch personas to that of a user, or better yet, even a couple of users that maybe you're sitting geographically distant from each other. And we'll edit files in one place and show that the user in the remote side gets to see those edits happening, and they'll make their own edits and hand them back and forth. And it's a pretty powerful, simple thing to see. And when you're done, that I don't believe you moment goes to, huh. And then the wheels start turning, and you start thinking about how you can change the way you do things. To Floyd's point, your access of data doesn't change, your ability to manage it simplifies.
And we have customers, for example, that have operations around the world, so that they're all, I mean, and again, we started this conversation with, the analogy of putting things on a floppy disk and handing them over the wall, making copies and managing by copy. But now the users on one side of the world and the users on the other side of the world, they're not working on copies. They're working on the same file, right?
Exactly it. Again, it just goes back to that thought process change, that idea that one view of the file system might represent one set of blocks on a storage entity. It might represent multiple endpoints around the globe. And just being able to have that automation in place now, the users are not dealing with having to copy files around or caching files in different places. They're working on the same files. Those files may have blocks in multiple places, but the changes that are being executed are tracked globally and consistently, and they are actually operating on the same data.
It's, I even think about it sometimes how, I've got a hard drive, right? In that hard drive, there's multiple platters and I don't know which bits of that file are on one platter or another. Yeah. Isn't what we're talking about here with a parallel global file system, a high performance parallel global file system? Aren't we treating all of the different storage types? And I mean, we're in close partnership with vendors that have incredible storage solutions, each with their own specialty. But aren't we now creating, through this parallel global file system, the ability for users and applications to just see their data and then let the orchestration at a file granular level just happen automatically in the background?
It's funny because we also started this kind of talking about just things that we used to do and take as granted as just normal activity. And I remember doing things like carefully planning out my RAID arrays to make sure that the data landed on the right drives and that, my hot spare was in the right spot and all this kind of fun stuff. And eventually you got to a place where within the storage system that didn't matter. You start thinking about, the media that's inside of those storage systems. To your point, we're partnered up with a handful of those people. And the media that they provide is the same media, whether it's sitting in, a NAS system or an object store or maybe even in the cloud. It's that file system interaction that makes it different. That's really what we're talking about is let's take that care. You no longer need to care, to your point, what platter is my data on, what cell is my data in. You shouldn't even really care which data center or which facility it might be in or which cloud, as long as it meets your business objectives. Well, then who cares? Like, let's let you redirect and focus on the stuff that matters.
That's a great way to say it, Brian. And so for all of you, and I really appreciate you all taking the time out of your day to listen to this conversation. What we're talking about is the ability for people to get better use out of their data, also better use out of their storage resources. When you're not copying data everywhere, you're not, wasting capacity. You don't get isolated capacity where because you can't separate a workflow, you've got excess capacity over here that you can't use, but you're oversubscribed on this storage over here. This conversation is really about how to leverage the power of metadata, file system metadata, but also custom information, business information that is important to your business than all of these that up until now we've had to deal with point solutions. So I invite you to go to hammerspace.com. We've got videos and white papers there where you can dig into more depth. Brian and I are always available, as well as a whole team of people who can at Hammerspace who can sign up for a demonstration to see how you can use this in your environment and how you can take your own existing data on your own existing storage and break down those silos and leverage that power of metadata to automate how you want your data to be handled, protected, moved, placed in a global data environment. Thank you very much, Brian. It's been a great conversation.
Thank you. Always fun, Floyd.
Okay, thank you, everybody. Talk to you on the next time.